This is the fourth and final section of the hypothesis testing chapter. And this is finding critical regions for a geometric distribution. So we know a geometric distribution is where we have trials until we get success. So P is going to be your probability of success, and X will be the number of trials until success occurs. Now, in all the questions we've been doing so far, what we've been doing is working out the probability, knowing what the value of X is. When we want to find a critical value, we work backwards. So we're now working out the number of trials needed for us either to accept or reject H0. Okay, so just a reminder of our formulae that we're going to be using. So either probability of X equals to X. Now, I don't actually think that we use this one because it's always going to be like an upper tail or a lower tail test, but it may be that we may need to use this. So let's write this down. Probability that X is less than or equal to X. So remember, lower tail test for where H1 is probability greater than, and I think in the book they use the number M there, or the letter M to represent that. So it's the opposite way around. So 1 minus P to the power X, and if we're doing an upper tail test, this is the working. So 1 minus P to the power X minus 1, and this is when H1 is going to be where there's a decrease in the probability. So in the questions that we're going to be doing, when we find a critical value, we are looking to work out the value of X here. Yeah, so that's what we're going to be doing, calculating what X is. That will tell us the critical region. So how many trials is like the maximum or the minimum needed for us either to accept or reject H0. So here we have Aisha wishes to test a 5-sided spinner numbered 1 to 5. She wants to see if it's fair. She spins the spinner and counts the number of trials needed, which is basically what we need to work out, number of trials needed, until she gets to number 1. Using a 5% level of significance, we need to find a critical region for one tail test of the hypothesis that the probability of getting a 1 on a single spin is less than a fifth. So first thing we do is to write down what's H0 and H1. Well, H0 and H1, H0 is going to be that the probability is a fifth. H1 is, well, it tells us that the probability is less than a fifth. So straight away you can write down that if it's less than, in this we do an upper tail test. So we'll just write that because we'll need it a bit later. We'll write down what the random variable represents, and in this case it's what is she counting? The number of trials until she gets the spinner to show the number 1. So the number of trials needed until the spinner shows a 1. So now we know this is a geometric distribution where P is a fifth. Now remember, we're doing an upper tail test, so the probability to X is greater than or equal to, now in this, X is the unknown, and the critical region is going to occur at the last value of X that we can get that's less than 0.05. Remember, the critical value is the last or first value in that critical region, the rejection region, and the rejection region is going to occur when our probability is below the significance level. Right, so this bit here can be replaced with, well, we know the probability that x is greater than x is equal to 1 minus the probability x minus 1. So let's now put those numbers in. X, so now it's 1 minus p, which is a fifth, to the power x minus 1. So x is what we're trying to find, is less than 0.05. So that is 4 fifths, or 0.8, to the power x minus 1 is less than 0.05. So to solve this, we need to do logs to both sides. Now, when we do logs to both sides, then you can just literally just write log in front of both sides. So I'm going to write I'll keep that as 4 fifths. Like this is less than a log of 0.05. Now I'm doing log to the base 10, doesn't matter really what base. So the x minus 1 goes to the front as a power, like this. 4 fifths, okay, that's 4 fifths, is less than log 0.05. Now the next step, we need to be careful, because actually I'm going to be dividing both sides by log of this, which is a log of 0.8. This is actually negative. Yeah, anytime you have the log of a decimal, a number smaller than 1, it's negative. Now, because we're going to be dividing both sides by a negative number, I need to reverse the sign. So this now becomes greater than the log of 0.05 divided by log of, let's write it now as 0.8, so that sign gets reversed. So x is going to be greater than log of 0.05 over log 0.8 plus 1, and let's see what we get from that. So that'll be x is greater than, let's type this in and see what we get. So if we do shift and minus, then we get log to the base 10 without having to use the other button, divided by, I'm going to do shift and minus again, 0.8, get that number, add 1 to it, and I get x must be greater than 14.425. Now x is a whole number, isn't it? Because it's the number of trials, so if it's greater than that number, x has to be 15. Okay, so 15 is my critical value. It's asking for the critical region, so that means that x is greater than or equal to 15. Now if we're not sure, we can always refer back to what we wrote down here. Yeah, you see that? X is greater than, and we found x is greater than or equal to 15 is our actual critical region, whereas that's the critical value there. Now part B, it says write down the actual significance level of the test in part A. That actually means working out what is this probability here. Yeah, greater than or equal to 15. So let's work that out using the formula. So it's going to be 1 minus a fifth to the power of 15 minus 1. So just using the formula. So that's going to be 4 fifths, or 0.8 to the power of 14. And we get 0.0, and it's 4398. So 4 decimal places, 1, 2, 3, 4. So that would be 0.0440. So that's 4 dp. Yeah. So probability questions. We'll go for 4 decimal places there. So that's the actual significance level. You could say it's 4.4%. Okay, in a particular city, a lobster card. That sounds very similar to Oyster card. Is used as a method of payment on trains. Very similar. The company that administers the card claims that only 1 in 1,000 cards will be rejected by the card reader at the train station. The station manager feels that the company is understating the proportion of cards rejected by the reader and decides to carry out a test. When he comes home on a shift at 5 a.m, that's early, or when he comes on shift at 5 a.m, he counts the number of passengers who pass through until he notes a passenger who has a lobster card rejected. They must have real fun with making these questions up. Right, using a 5% level of significance, find a critical region for a one-tail test of the hypothesis that the proportion of rejected cards, lobster cards rejected by the reader is greater than 1 in 1,000. So step number 1, H0 and H1. So H0 is going to be that the probability that these cards are rejected is 1 in 1,000. And H1, it's going to be that it's greater than 1 in 1,000. Yeah, so we know we're going to be doing a lower tail test because it's greater than. So let's just write that down. Lower tail test. Right, now we write down what our random variable x stands for. So this is going to be the number of cards before read by the reader before one gets rejected. So the number of cards read before one gets rejected. It might be better worded as it's when the first rejection occurs, isn't it? Yeah, so it's the number of cards read before a rejection, or until one is rejected. That would be better. So it's not really before. The number of cards read until, it's better, until one gets rejected. Right, so we have a geometric distribution with 1 over 1,000 as our probability of success, and we're going to be working out the probability that x is less than or equal to, lower tail test, x is what we're trying to find, that's the unknown, and we want to work out the value of x that's going to make the probability of that drop below 5%. Right, so first of all, the probability that x is less than or equal to x, the way that we work that out is 1 minus p to the power x is less than 0.05. Now p is 1 in 1,000, isn't it? So I might change the decimals now. 1 minus 1,000th is going to be 0.999 here to the power x is less than 0.05. So from there we would take away 1 from both sides. 0.99 to the power x is going to be less than 0.95, negative 0.95. Then I'm going to multiply both sides by -1, which means reversing the sign. So I have 0.999 to the power x is greater than 0.95. Now we can do the log to both sides. So log 0.999 to the power x is greater than 0.95. The x can go at the front like this. Whoops, and log on this side as well. So log 0.95. Now, the next step, I'm going to be dividing both sides by log 0.999. Now remember, when you do the log of a decimal, a number smaller than 1, you get a negative. That means we need to reverse the sign again. So x is going to be less than log 0.95. So these are log to the base 10 divided by log 0.999. Now what does that give us? X is less than what? So log 0.95 divided by log 0.999, and we get 51.26. So x is less than 51.267, like that. Now, because it's less than that, we go to the biggest whole number that it can be. Not like the last one, we went to the smallest number it could be. So the critical region is going to start when x is 51. So that's a critical value. The critical region will be x less than or equal to 51. So there's our critical region there. And then part B, the actual significance level. So now we just work out what is the probability of x less than or equal to 51 on our calculators, which means doing 1 minus, and then it's 1 minus p 0.999 to the power 51. And if we do that, 1 minus 0.999 to the power 51, and we get 0.04974. 4 comes after it, so that's fine, we'll leave it like that. 4 decimal places, so there's our answers. Here we go, done. I should now be able to do exercise 4D on pages 71 to 72. So just as a quick recap, these are questions where we set H0 to something, we set H1, either greater than. So if you've got greater than, you know that's a lower tail test. If it's less than, you know it's an upper tail test. Yeah, so that's the first thing. Then we need to set what x is. So it's going to be the number of whatever, number of something until something. So it's going to be something like that. X is going to be our geometric distribution when we have P. And in these questions, we're trying to find x. This is the unknown here. Yeah, or it may be that it's greater than or equal to. So yeah, x is the unknown in this case, unknown. And it's normally things where you're looking for it to drop below 5%. Okay, so that would be a 5%. level of significance. Now, we know that when we see less than or equal to x, like that, we know that the formula we're going to be using is 1 minus p to the power x, and when it's greater than or equal to x, the formula we're going to be using is 1 minus p to the power x minus 1. So x is what we're trying to find, and because we're trying to find a power, we use logs to solve and find x.